Welcome to the class. In this lecture, we are going to discuss about types of hammers, what are the construction equipments we have, and if based on that equipment, in this topic, in this lecture, we are going to discuss about what are the types of hammers and what are the different types of uh, hauling equipments, material handling, and erection of the structure equipments. So here, in this lecture, we are going to see about types of different types of hammer equipments which are used for the purpose of any material into the ground surfaces or removal of materials from the ground surfaces. Here, the dropped hammer, uh, no external source needed, and mechanism to lift the hammer by a cable and drop it by gravity only. The solid mass of metal or cast iron of weight 1 to 4 tons, the height of fall is 1.5 to 6 meters, and number of blows is 4 to 8 per minute. It is slow process but efficient, not in use now. The types of hammers we have is one of the type of hammer is of drop hammer. In this hammer, there is no external source and required, and here the mechanism we use is to uh, use this type of hammer is of by lifting the hammer by a cable and drop it by gravity. So here by driving with the pile of any material into the soil surfaces, so we use drop hammers. They directly put some pressure on these sources, so they can deliberately pump the material which is required to be driven into the ground, so that these drop hammers which are in it may not require nowadays, these equipments are not in use, which are not in use, so they use by uh, gravity only. There is no other mechanism which is used for uh, dropping off these type of hammers. So the height of fall for the hammer should be of 1.5 to 6 meters, and the weight of these iron hammers is of 1 to 4 tons. 1 to 4 tons. So the number of blows they can blow on the material is of 4 to 8 blows, which requires efficient effort by the workers to fastly hang the hammer by a cable to the lift, and so the maximum number of blows it may give is of 8 per minute, and it is a very slow process but efficient. And these process which are not in use nowadays, the single acting hammer. In this, the hammer is lifted by steam or compressed air, drop it by gravity only. The weight is of 2 tons, and the height of fall is of 1 meter. The number of blows it requires is 60 blows per minute. Here, these single acting hammer, the hammer is lifted by a steam or compressed air, and these are dropped by gravity only. The weight of these hammer is of 2 tons. The height of the fall of this hammer is of 1 meter. The total number of blows they can blow on a object is of 60 blows per minute. The double acting hammer. The hammer is lifted and lowered by steam or compressed air. The weight of this hammer is of 500 kgs. The effect will be like 3 tons of load that is put directly on the surfaces, which has to be driven into the surface. So these double acting hammers, they blow a number of blows of up to 100 to 200 blows on the surface of the object which is to be driven into the surface is of 100 to 200 blows per minute. Here, the differential acting hammer. The hammer is modified form of double acting hammer. The weight is of 2 tons. The height of fall is of 1 meter. The number of blows it can blow on the surfaces which is to be driven into the earth surface is of 100 to 200 per minute, and the same pile can be driven within half time, saving 30% of the stream or compressed air. The diesel hammer. The diesel imparts, see, this diesel hammer imparts compression, impact, and explosion energy to the pile. So here the working principle of these hammers, the rise of the piston to start. Here you can observe the rise of the piston is here, and injection of diesel or fuel and compression is here, and impact and explosion can be seen in this image. So the rise of the piston which helps to lift the internal piston to far distances, and also in this piston it can inject, it is injected, and they have suction type arrangement, and while we lifting these piston to start the action of driving up the pile here, the diesel fuel and compression can be generated in these, the injection of diesel fuel and compression, and impact and explosion can be seen in the third image. Impact and explosion can be seen in the third image. So the exhaust ports exposed and the gases escape and puts pressure on this pile by constant applying of this load. There is any ports or exposed gaps can escape from these pipes, vent pipes like arrangement here. Is there any gases or any voids present in these? Fear can be escaped by this exhaust while the load is applied by the piston, and draws fresh air through the exhaust. After completing of this blowing of impact on the piston, these any gases or voids which are escaped, and if the piston is raised to up to start the functioning of the hammers, the freshly air they draws. These oils can draw fresh air through the exhaust ports. Vibratory hammer, very effective in driving piles through non-cohesive granular soils, very effective in the driving of piles through non-cohesive soils, and this pile is driven by making vibrations. The vibration can be produced by electrically or hydraulically. So the penetration rate can approach up to the penetration rate can catch up to 20 minutes or 20 meters per minute in moderately dense granular soils. Moderately dense granular soils. So here it can be used with another method, also the hauling equipments we have seen in the previous lectures, and these are the drum trucks, side drum and bottom dump trucks. These are the equipments which are used for the dump trucks, and equipments which are used for handling of materials and erection of the structures. Vertical motion devices. These are the vertical motion devices, the handling devices for hoisting equipments, which we have seen in previous lectures. Block and tackle, that is block and tackle, the oldest and simplest one, use only mechanical power in expensive device but waste of man power. Here a pulley-like arrangement. Here a pulley-like arrangement is given, and the load has been suspended at one end and has been driven or pulled by a man through that pulley to lift these load vertically up. So this requires huge manpower, and this is very cheap equipment which is used in the construction sites. The types of handling devices. Second one is winch. Here, by winding rope or cable on drum, the vertical movement is obtained. Greater mechanical advantages than block and tackle. used to load heavy equipments, heavy equipments into ships or ships and any second one is of winch, the vertical motion devices which helps the lifting up of the load, the raw materials directly heavy load equipment into the ships. These are also used for greater mechanical advantages than block and tackle. So this winch like arrangement comes with a winding rope or cable or drum. Vertical movement is obtained here. This is the winch equipment, and here in this image we can observe there is an arrangement here to hold or lift up or buckle the load which has to be lifted up, and these are the operators. If a button is pulled without any uh, requirement of manpower here, these can mechanically lifted up. And vertical motion devices, the hoist which are operated between fixed guide rails operated by hand, compressed air by electric power. The same as elevators, but operator does not go up, but operated from one point to other. Elevators, these are same as operators can go up with the load. The electrical type of elevator is best. If not, hydraulic type elevator is used. If not, if in the construction areas the electrical type of elevator is not available, then we use the hydraulic type of elevator. So these elevators, these lift the loads vertically from one floor to another floor, and these are the horizontal motion devices, the hand trucks. The simplest one still in use that require large manpower to use. The major advantages are the cost of these equipment, the hand truck equipment which is cheaply available. So the flexibility and the easy transportation from one place to another place. These are the hand trucks or trolleys which are used in railways, which are used in railways or any grocery stores to lift the amount of materials and transport them from one part to another part. These equipments, these hand truck equipments, are also helpful in oil industries, which are loaded by the drums of oil and can be transported within the site to export to the main vehicle, which is to be exported to far distances. Types of handling distance devices. Here, the horizontal motion devices, which are narrow gauge railroad. These are very expensive, and are used in industries like blast furnace, copper refineries, steel rolling operations. So horizontal motion devices, narrow gauge railroads, nothing but narrow gauge railroads. They are very expensive. They are very expensive. Used in the industries like blast furnace, copper slags, copper refineries, and steel rolling operations. Tractors and trailers, most widely used. Different trailers can be attached to tractors, less costly than the narrow gauge rail. The horizontal motion devices, these are the known as skids, wheeled on a plane trolleys over which the materials are loaded and picked up by lift trucks, and are used to transfer load from the position to position. The horizontal motion devices, pipeline and pumps are used for horizontal transportation of materials They are used to transfer fluids and gaseous materials, and they require these horizontal motion devices require high maintenance and are to be properly transported by using this mean of transportations. Combinational devices. Here, the tube which is used for both horizontal and vertical movements may be straight or spiral forms used in packing industries, railway, and air terminals. This is a tube. Here, you can observe the raw materials or the manufactured materials that can pass from top to the carrying vehicles to the carrying vehicles, which are used less manpower and can be transported easily from place to place. The types of handling devices. Here, the combination devices, the lift truck, which is same as skids, but provide large platforms to lift and place the materials. They uses mechanical power to move materials from one place to another place. These are the lift truck, which is used in the same method as skids, same method as skid. So, if you using these skids, which are wheeled arrangements on a plain terrain or a plain platform, so, which is in the similar manner of a lift truck, and these are provided with a large platform to lift and place materials, which are used as this mechanical power to move materials from one place to another place. The combination devices here, the fork lift truck, it is provided with a fork which receives the load at uh, ground level and elevates hydraulically to desired height. Here, in this forklift truck, we have seen previously that a forklift truck is having two arms which are to be maintained the raw material on the uh, lift-like arrangement here, and they can receive the loads from the ground level and carry hydraulically to desired height. So, cranes, derrick cranes, and their uses. These are the derrick cranes, mobile cranes, which we have seen previously, and overhead crane. These are overhead crane and a traveler crane. Here, the overhead and a traveler crane, which are different in their uh, process. It has a truss structure welded from angle bars and channels. The ladders are provided for ease. They can be assembled and dismantled, which are used in industrial and residential high-rise buildings, also commonly used in industrial plants with steel structures. These are tower cranes. Previously, we have seen about these are belt conveyors. Those are most popular, which are consists of a belt running over a pair of end drums supported by a series of rollers called idlers. The middle sag is provided to prevent the spilling of materials, and the advantages can handle light, heavy, dry, wet, soft, coarse materials with high speed and carries horizontally and inclined lighter in weight. Controlled discharge can be seen by using these belt conveyors. Here you can observe the raw materials or the materials which are transporting from one place to the another place of the site. Here, these raw materials are placed on the belt conveyors. They are moved towards to the distribution point. These are also belt conveyors. The screw conveyors. Here, these are used for handling granular or pulverized materials. Quantity is less compared to belt conveyors. The cost is very low, and they consist of a helix mounted on a bearing at the ends and at intermediate points. The length is 65 meters with an inclination up to 35 degrees. These are screw conveyors. They can less uh, they can lessly transport the materials to the destination point, and they mostly used for granular size purpose of raw materials, which is to be transported from one place to another place within the site. And the cost of these equipment is also very low when compared to that of belt conveyors, the bucket conveyors, which I have seen in previous class, the aerial transportation, the cableways, which are used in excavation works of dams, quarries, construction, etc. So these cables are helpful. The loads are hoisted and moved vertically, also used in transporting concrete over large area. The ropeways, here long distance movement, endless rope with two and endless rope with two and towers and supported by a series of pulley mounted on intermediate tower. They separate handling and support ropes. Here you can see these are the cables and ropeways which are used to carry for a smooth passage of materials from an from top of the ground level, and these are much costly, and they can give maximum results while carrying these loads. If these are used in the river beds for construction of raw materials from one side of the river to the other side of the river, and also by transporting of raw materials to the construction sites. These are the cables and ropeways which are also used in the hilly regions for easy transportation of the materials. When the terrain is not smooth, the roads which we lay is not possible. These cables and ropeways plays a major vital role on transportation of materials from one place to the another place. These are the cables and ropeways. The batching and mixing and tracing of concrete. Here, the batchers, the manual batching and semi-automatic batching and automatic batching have used in the batching up of these concrete. The proportionating the ingredients of concrete for a particular mix, the weight batching is commonly used. Concrete batcher, here the equipment which is used for the concrete batcher, and the factors governing the mixing are the correct setting of machine, the proper cleaning of blades, sequence of material charged, and the time supply of water, direction of inflow, speed and type of mixing types, drum type mixers, tilting and non-tilting, and pan type mixers. Here, these are the drum type mixers, tilting and non-tilting. Here, this wheel is helpful for tilting of these drum-like arrangement. So in this is the inlet for uh, aggregates, coarse aggregate, water, and cement to be discharged in there. And inside of this drum, you can see there are blades which revolves with the which revolves around with the drum. So if a drum arrangement moves, the blades within itself can move freely. And if these blades and the entrance of these has been cleaned and maintained, so the batching can be done perfectly. Here the amount of water which we discharge into the drum in the open of this drum allow the additional water arrangement should be taken care on making of concrete. Here, these wheels, by while unloading, this wheel can be rotated, so the drum with the entrance will be formed to the downwards, and the concrete inside can be pulled out by a man who has the digging out of the material or concrete which is in the drum. Here, these are also drums, tilting and non-tilting. Concrete placers, usually done through buckets carried on railroads or tracks. These dump trucks and belt conveyors are also used. The cableways can be used, or the hoisting of buckets may be done with the help of cranes. Concrete placers. These are the equipment that can directly, here you can see there is this concrete carrying machinery, drum-like arrangement carries and discharges the raw material, and by using these conveyor-like arrangements, they can be dumped to the site. The proper enrouting of these drum-like materials, drum-like arrangement vehicles cannot be possible to come near to the unloading site. So these unloading can be done by using of these concrete conveyors, belt conveyors, so that the concrete which is unloaded on the conveyors, they can be moved towards the batching site and can be discharged here. You can observe in this image here. This is the concrete discharger, concrete places. They can be moved. And these pipes, these are the inlet pipe which suck the concrete out of the machine and places in the site for the filling up of this concrete. Here, this is the hydraulic arrangement which is used for large distances to be filled areas. There is no possible way of running of these machines near to the site. Dredging equipments. These are used for excavation from riverbed, lake, sea for the purpose of deepening them. The types are dipper, dredger, backhoe dredger, bucket or ladder dredger, suction dredger, and grab dredgers. So the dipper dredger, which is usually mounted on floating platform, the boom can rotate through 180 degrees. Production rate is 50 cubic meter per hour. The bucket size is 4 to 6 cubic meters. The dumping range is about 30 meters from the mounted area of these dipper dredgers, and the depth is of 15 meters, and these are suitable for rock material, dredging clay, or confined spaces of docks and narrow channels. The low production rate and a less depth can be observed in the dipper dredger. Here you can observe the arrangement of the equipment for dipper dredger. These are bucket-like arrangement can bring up to 4 to 6 cubic meters of materials which is to be dug out. Raw materials which is digging, and 15 meters depth can be gone for this, and a 30-meter arrangement can be seen in this equipment. These are the early stages of equipment. The backhoe dredger, it is usually mounted on floating platform. The production rate is of 100 to 400 cubic meter per hour. The bucket size is of 1 to 6 cubic meters. The depth is of 80 meters. For the dipper dredger, it is of 15 meters depth, and here we can observe 18 meters of depth. These are suitable for rock materials, trenches, etc. Backhoe dredger, which can go up to a depth of 18 meters. Backhoe dredger. The ladder dredger, it is equipped with bucket elevator mounted on a badge. The parts, a cable arrangement wheel and containers, it is suspended on a steel ladder and are suitable for excavating soft ground or sand or gravel. Bucket ladder. Here, these are the bucket arrangements which can collect the materials which has to be collected from this bucket ladder. Ladder dredger. These are the ladder dredgers. They can collect the materials on the bottom of the surfaces and can be filled into the buckets by themselves and can be lifted towards to the unloading arrangement. The grab dredgers, it is equipped with grab suspended by a cable. The grab is extended by operating the boom of a crane. The dredger has 1 to 4 boom cranes mounted on it and are suitable for excavating soft ground or sand, gravel, and rock removal also. The grab dredger is in this image you can observe. These grab dredgers can be maintained by the cables or hydraulic pumps that can grab the material beneath the surfaces and can be lifted to up. Here are the images of this grab dredger. The suction dredger. Here, similar in operation, except it consists of a pump excavator mounted on a barge. with a suction line and supported on a ladder. The plain suction dredger, free running granular materials can be sucked out and can be pumped in a distances. The cutter suction dredger. So here 3000 cubic meter per hour, the output capacity of this cutter suction dredger and a 6 kilometer pumping range. The wheel suction dredger, which is of 200 to 3000, sorry, 36,000 cubic meter per hour output capacity can be obtained by this wheel suction dredger. The trailer suction dredger here 300 to 11,000 cubic meter per hour output capacity and depth of about 10 to 30 meters can be observed. This is the plain suction dredger. These are plain, and this is cutter suction dredger and wheel suction dredger. Wheel suction dredger. Here they cut the materials beneath the surface and can be the cutted material can be sucked out by using of this suction wheel arrangement dredger and bring these such an amount of materials beneath the surface which is cutted by the wheel arrangement there and can be pulled towards to the unloading point. This is the trailer suction dredger. The suction pump, the trailer arm, and sanding popper. Trenches, wheel trenches. So the wheel trenches are wheel trenches. They consist of a pair of circular rims connected by U-shaped buckets or cutters. The self-propelled, the excavating device is connected to a means of conveying with a width of 12 meters and a depth of 3 meters. These are operated by a cable drives. These are mostly used for laying water, gas, or pipelines, and also telephone cables, drainage receivers. These are the wheel trenches. The ladder type of trenches, similar to wheel trencher, except buckets are provided with chain links or ladder type frame or boom. The major advantage of the using of these ladder type trenches are faster, cheaper, and takes necessary depth and continuous process. Ladder type trenches, tunneling equipment, the rock drilling equipment. Here, the percussion type and the rotatory type. Here, the jackhammer, which is a handy equipment weight of about 25 kgs and depth is of 2.5 meters to 3 meters. The drifter, heavy rock drillers, weight is of about 45 to 70 kgs and dug deep into the depth of 9 to 12 meters. The rock drilling equipment, the truck mounted drill, the truck mounted easily mobility, which can be seen and can drill up to a depth of 15 meters and holes along angle and vertically down. The tunnel boring machine. Thank you and meet you in the next class.